Hello everyone, in this video I'm going to go over how to factor quadratic equations. So by definition, a quadratic equation is something that has an x squared term as the highest degree term. It might add a bx plus c term, but it really just needs this, an x squared. As long as it has an x squared and no other power higher than that, it's a quadratic equation. But most of the time in this class, we're going to be seeing them where you have some number, some coefficient in front of the x squared, plus some number x, plus some constant number c. It doesn't have an x by it. And so the purpose of that is it's when you factor it, it makes it easier to solve, meaning it makes it easier to figure out the x-intercepts. And I'll go over that in more detail in later videos. This is just really an introduction to factoring. So in this, it says solve the following quadratic functions when a equals 1. Alright, so remember, a is the coefficient by the x squared. So if there's no coefficient by the x squared, then a does equal 1. Okay, so before I do any math, I'll just quickly label this. I have 1x squared. I'm looking at 1x squared right there. I could throw a 1 there and not change anything. B will be 2 and C will be 1. Okay? So what you're going to want to do is, I like to draw an X. You're going to want to do A times C. So that's 1 times 1. So my factors of 1, that add up to the middle number 2. Okay? So you need to think of two numbers that multiply to get 1 and add to get 2. And that's simply just 1 and 1. 1 times 1 is 1. 1 plus 1 is 2. So we take these two. These are my factors. And we just write it as x plus 1 times x plus 1. And we set it equal to 0 because eventually, not in this video, but eventually, you'll use that to solve where the x-intercepts are. Now, if you have x plus 1 times x plus 1, you can also rewrite that as x plus 1 squared because you have a little less to write if you write it like that. But either one of those is acceptable as the answer. Okay, moving on to this next one. This is a bit out of order, so all I'm going to do is I'm just going to rewrite it in order and make sure I don't change any of the signs. So it said plus 3x originally, and then it has a negative 10 at the front, so I'll say minus 10 equals 0. Okay? So now I'll just say a equals 1, b equals 3, and c equals negative 10. Okay, so to factor this, you need to think of the factors of a times c. So 1 times, and this is a negative 10. So factors of a times c are 1 times negative 10, so that's negative 10. And they need to add up to get that middle number 3. So I'll put a little x here. Two numbers that multiply to get negative 10 that add to 3. Alright, so think about it. 10 is 10 times 1 and 5 times 2. I know if I do 5 minus 2, I'll get 3. And so 5 plus negative 2 is 3. And 5 times negative 2 is negative 10, so that works out. So these are my two factors. So I take that and I write a little statement here. X, and it was a positive 5, so x plus 5 times x minus 2. Your answer is always going to look like this. These are called binomials. Okay? The x plus 5 is one binomial, and the x minus 2 is another binomial. Right here in the objective, I said I will use the factors of a times c to factor a quadratic equation into two binomials. So that's what we're doing. And then don't forget to add on the equals 0. Again, we'll deal with that later on, but right now, this is the final answer. And that's that. So these first two examples are when a equals 1, and then looking at this third example, a doesn't equal 1. Nor does it have everything on one side. If you notice this little formula right here, ax squared plus bx plus c, everything's on one side. So if you see an equation and not everything's on one side, you need to get it over there. So I'm going to add 16 to the other side. And since 16 is not a like term to 2x squared or minus 12x, you have three terms. When you're doing this unit, you'll see that most of them have three terms, but it's not all the time. Just make sure you're not adding two things together that aren't like terms. So this is a does not equal 1 here. A equals 2, but I said in the instructions a would equal 1. Look at what they have in common. These are all even numbers. Okay, so if you see something and they're like, oh, they're all even numbers, then you can factor out that even number and make things smaller, so to speak. So these are all even numbers. They all share a factor of 2. So what I'm going to do is I'm going to factor out a 2 from everything. So when you factor out a 2, just put the 2 on the outside, and it's like you're dividing everything by 2. Okay, you might recall this from when you've done greatest common factoring. So if I factor out a 2, meaning I divide everything by 2, that'll leave behind an x squared. Minus 12x turns into minus 6x, and 16 turns into 8, and it still equals 0. So this is my simplified version now, and see, I just had that 2 on the outside and the rest is in parentheses. If I were to go back and multiply it, I would just go right back to the original right there. So that's how you know you did it right. I didn't really change anything. I didn't change any specific values. So anyway, moving on. I need to look for the values of a times c. So a is still 1 here since I factored out that 2. So my values of a times c would be 1 times 8. So let's see here. Factors of 8 that add to negative 6. Okay, factors of 8 that add to negative 6. Well, let's see here. 8 is 4 times 2 and 8 times 1. So let's see here. 4 plus 2 is 6, but not negative 6. So maybe if I make them both negative, negative 4 plus negative 2, that'll equal negative 6. When I multiply them together, negative 4 times negative 2, the negatives will cancel and I'll get a positive 8. So I'm good. So therefore, I say my factors are 2, because that 2 from earlier, and I just write it on the outside, x minus 4, and then times x minus 2 equals 0. And that's it. That's where we'll stop for there. It's factored. So just don't forget about that 2. So you just have to keep an eye out for that. I might throw that at you every now and then, where you'll have a greatest common factor. So if you see everything, you're like, oh, that can be divided by 3 or 2 or 4 or something like that, do that first, and that'll make everything on this part easier. You'll have much smaller numbers, and your factors will make more sense, I think. Okay, so I'd like for you to try the next two on your own, and I'm going to pause the video, and you'll see it'll just jump to the answers being there. I'll do a quick explanation of them, but try it on your own. Pause the video right now and try them on your own. Okay. Okay, so here I had 1 times negative 8, because it was minusing the 8, so I'll treat it like a negative. That's factors of negative 8 that add to positive 7. So factors of negative 8, 4 times 2, 8 times 1, make one of those negative. So if I make 8 times negative 1, that makes negative 8. 8 minus 1 makes positive 7. So therefore my answer was x plus 8. X minus 1 equals 0. Okay, so this one, the minus 16 was on the other side of the equal sign, so I added it over. And so I have factors of 1 times 16, so that's factors of 16 that add up to 8. So I know 16 is 8 times 2, and 16 times 1, and 4 times 4. Well, 4 plus 4 also equals 8. So then my factors turned into x plus 4 times x plus 4 equals 0. And since you wrote the same thing twice, you could simply state it as x plus 4 squared equals 0. And that'll wrap things up for this video. Again, just keep in mind, the one that was different was this one where I factored out a greatest common factor of 2. You'll want to look out for that when you have a number in front of the x squared. So when a is not equal to 1, so to speak. Now, when you factor it out, that might bring a down to equal to 1. But notice how I didn't mention anything about a greatest common factor on these other ones because I had no coefficient in front of the x squared. So if you don't have a coefficient in front of the x squared, there is no greatest common factor between them. Um, Nothing greater than 1, at least. So that's just something to keep in mind for the future. Um, Stay tuned for our other videos and other examples, like when a does not equal 1, like on these 5. Alright, bye everybody.